Today is Wednesday, October 26, 2022. Clear. None of the weather satellites showed that it was going to clear up tonight, but mysteriously it did so. It's a couple days after the new moon, so the moon is going to rapidly start to become a factor in observing. You can see Jupiter up there, Saturn is culminating to the south. My goal for the evening is to capture the M31 Galaxy group, and that's going to require that I have a couple of galaxies very close to M31, the Andromeda Galaxy, but there's a couple of more distant ones that may or may not be blocked by the roof line, and I added a couple of NGC galaxies as well. So here I've already called up Messier 110. And you can see it's giving a spectacular view. Now we have to give it a chance, however, to stabilize because I just walked in on the observatory. So there's the view just walking in. Very extensive. I'll show you the data in a moment. But I'm surprised to get that good a view tonight because there's an awful lot of water in the atmosphere. You'll also notice the telescope is pointing pretty close now to the roof line of the observatory, so I'm going to go after a couple of further north NGCs before I get too much further along here. We'll come back to M31 in a moment. So here's the data on NGC 147. 147 is a satellite galaxy. It's part of the local group of galaxies, but it's gravitationally bound to some degree to M31, which may very well be the most massive galaxy in the local group, which consists of more than 20 galaxies. And 147 is magnitude 9.5, is smaller and fainter than the galaxy we just saw, M110, but should give quite a good view. It's located about 2.4 million light years distance. That places it a couple 100,000 light years further out than Messier 31 itself. So here we go, let's take a look. Right now I'm using settings of 128 and 36. 128 flood, 36 auto gain control. As I said, there's a lot of atmospheric water. You're seeing the phasing out of the old image of Messier 110, and I synchronized to 110, so it should be NGC 147 should prove to be pretty close to the center of the field. However, I'm noticing the scope is being possibly, and I'll have to check this out, being blocked partially by the roof. And I'm going to need to turn this light on again to see if that's the case, requiring a bit of a reach over here. And yeah, you can see part of the aperture of the scope is being blocked. And had it been earlier in the evening, I'm getting out a bit late, we would have been able to probably get the full aperture of the scope. But boy, we're not losing that much. So here you can see NGC 147 slightly blocked by the roof line, and hopefully I'll get another view at a later point tomorrow or the next day, but earlier in the evening when I should be able to get a better view. But there's the galaxy, NGC 147, faintly arrayed, about the same size as M110 but not nearly as bright. So 147 should be the furthest north of the galaxies that I want to observe. So let's go ahead and have a look at another one. I think it's NGC 205, but give me a moment to verify that. Actually is NGC 185, not 205, also a galaxy in southern Cassiopeia. About the same size, maybe more oblate, magnitude 9.2, 12.5 arc minutes by 10.4. It's 2.1 million light years distant, so even though it's kind of aligned up with 145, it's actually in front, but further towards the north from our point of view of M31. So let's go have a look at that. Now the scope shifted only lightly, and there may or may not be some blockage of the aperture. I don't think it'll be much. So I'm having to hold the camera off at a distance. Well, you can see right away that 185 has a far more condensed core than our last study, I believe, was 145. We've got a brightish core with not as much extensive nebulosity. So one thing I got to do is turn off the light because it is reflecting off the roof a little bit, and it's adding that red tint to the screen. Let me see if I can reach over and turn off the observatory lamp. By the way, I really don't need to use the observatory. Using a real-time imaging like this, you really aren't as concerned about your eyes being affected by local light sources. One of the great virtues. This particular galaxy almost looks comet-toast, doesn't it? It's got a bright star near the core, which gives the sense of being the point of the comet. And then it's got a trailing section behind it. It looks like it kind of heads from the middle of the screen off towards the 2 o'clock position. Now, I am not sure how good it looks on the camera because I'm really having to extend my arm in order to see this. Now, I have seen from very good locations like Crater Lake, both 185 and 145 reasonably well, at least as faint clouds of light, without much in the way of features, from really dark sky locations such as Crater Lake, where the sky was transparent down to about magnitudes, stars were visible to magnitude 6+. Keep in mind, we're looking now through a lot of water haze. I'd be surprised if we could see stars as bright as magnitude 5, even if I were fully dark adapted. But that's a very nice view. Much better than I've ever seen through a small scope. Once again, I would say the rule of thumb is you're going to gain about 3 times in aperture whenever you do real-time imaging and you push the flood and the gain control up towards the limits. And this is an image that's being regenerated maybe every 9 seconds based on 6 1.5 second intervals. Not bad. Here we have another galaxy in Cassiopeia. I'm not sure if I'm going to be blocked by the roof or not. 52 degrees north is 47 degrees north should be feasible if I caught it early enough in the evening. This is NGC 278. Now, I'm not going to tell you whether or not this is a satellite galaxy of M31. There are clues here, however. It's magnitude 10.8, roughly 2.5 by 2.5 arc minutes in size. It's an SB spiral located 39 million light years distant. So let's go and have a look at it. Okay, once again, we are kind of grazing the roofline of the observatory, but I think we're getting full aperture here. So let's give this baby the requisite 9 or 10 seconds it needs to generate. Hopefully, as the old imagery disappears from the CCD display, I won't disturb, through my motion on the deck floor here, the regeneration of the galaxy. But it looks to me that this is a pretty bright galaxy. It's got an incredibly bright central core. It's basically a face-on presentation. You can see the brighter spiral arms off to the 12 and 6 o'clock positions. Very bright, very compact. This is a full-blown galaxy. Certainly not, however, at its distance and size, anything that rivals M31 itself or our own Milky Way galaxy. But you can see some spiralicity in the arms. I am quite impressed with that. Now, I don't know why the screen itself is flashing and fluttering like this. There can be some feed problems from the CCD imager to the screen. But I am very impressed with this. And what it should do in the future is probably come back at a higher magnification so we can tease out more of the detail in those spiral extensions to the north and to the south. Okay, taking a quick break from galaxies, and for something that's much closer to home. We've got the NGC 7662 planetary in Andromeda. Its magnitude's 8.6. Its largest 17 by 14 arc seconds. probably not going to be displayed that large. The central star is magnitude 14. It's located 6,400 light years distant. And 42 degrees north should fully be disclosed within the aperture of the telescope. So here we go, the evening's planetary nebula. Ordinarily with planetary nebula, one thing you do want to do is you want to have a filter on the system. Largely so that especially planetary nebula that are smaller in size distinguish themselves more fully from any nearby stars. One thing I am noticing is you can see that ring off to the right is unlikely to be the planetary nebula. That is an exclusion zone that apparently the CCD imager at high exposure times protects or somehow distinguishes between overbright parts of stars. So I couldn't tell you whether or not the planetary is in the screen at this time, but at least we're envisioning the field in which the planetary 7662 would be located. Okay, our next study is going to be NGC 7640. Excuse me. It is a galaxy in Andromeda. Magnitude 11.3, 10 arc minutes by almost 2 arc minutes. This should be a fairly edge-on spiral galaxy located 29 million light years away. 40 degrees declination should fall well within the range of the work envelope of the observatory telescope. There we go. Once again, we're going to give it the time it needs to generate an image. We're looking for a long, thinnish, nearly edge-on galaxy. Now I'm seeing something that appears to be the galaxy with a north-south orientation. But from this angle, the screen is presenting it as though it were a shadow, and you can see it at the tip of my finger there. And I can't tell you whether or not, yeah, that's the galaxy, because it's hard for me to get my head lined up with the screen. I'm hoping you're getting an image there. But that's most certainly an edge-on presentated galaxy with a brightish central core, shooting off due north and south on the screen, so from the 12 to the 6 o'clock position. I'm really trying to line up my eye to tell, but I'm hoping the video camera I'm using to capture this image with will display it nicely. So, there we go. NGC 7640 Galaxy. Return to Messier 110, a galaxy in Andromeda, magnitude 8.1, some 920 by 11, 19.5 by 11.5 arc minutes in size, so quite huge, 3 million light years distant, which pushes it out another 500,000 light years away from the Andromeda Galaxy on the further side. Should have no trouble seeing all of it at 41 degrees north. Let's have that look. Okay, now we're going to let the galaxy formulate itself, and nicely it's coming out somewhere near the middle of the screen. The core is very brilliant. Huge extensions to the 12 and the 1 o'clock position. Nice structure for an irregular galaxy. Most satellite galaxies are irregular. They get disturbed by the gravitational fields of their larger central bodies, such as Messier 31 or the Milky Way galaxy. So they tend not to organize themselves quite as nicely. But this galaxy, M110, must have enough mass that it is actually able to pull itself towards the core, which means it's overcoming the neighboring gravitational field of the M110, or the M31 galaxy, which, as I may have mentioned before, is the co-regent galaxy with our Milky Way of the local group of galaxies. Very nice view. Now, we're going to go look at something next, which is M32, and that is going to look, as I was saying, we're going to move on to M32, another satellite galaxy of M31. It's in Andromeda. Magnitude 8.1, 8.5 by 6.5 arc minutes in size. I've never seen it that large. It always looked like a smallish globular cluster at the eyepiece. 3 million light years distant, which also puts it basically beyond the M31 galaxy itself. So declination 40 degrees. This should not be any difficulties. Did not have to move far. You can see the image formulating on the screen. Oh, so bright that the core is being masked by the CCD imager. Something I'll have to play with in the future. But you can see why I might think that it was a globular cluster at the eyepiece very easily. There are some wispy extensions, especially to the 6 o'clock position. In fact, as I line my head up better and better, which is not easy with the screen, I am seeing more and more of the extensions of this galaxy. Now, you can understand why you might assume this galaxy would be a globular cluster, but you'll notice, as brilliant as it is, there's no really resolved stars anywhere on the outside of its perimeter. And you wouldn't expect to be able to do so, because you would have to have some pretty bright stars to be able to, 15th magnitude stars at 3 million light years would have to be of some tremendous intrinsic brilliance. In fact, most stars that you can ever find through a smaller telescope such as this, even using imagers in galaxies, tend to be novel displays, not resolved components of the galaxies themselves. Notice there's a slightly oval presentation to this M32 galaxy, satellite galaxy of M31. All right, on to the main show, which we're not going to be able to fit in the screen, but we'll do the best we can to sweep it. I mentioned before, Messier 31 is co-regent galaxy. Oh, look at the distance. All right, co-regent galaxy to the Milky Way. So I had remembered that M31 was some 2.5 million light years distant, but this database is showing it 3.4. So those other galaxies that I mentioned as being further away satellite galaxies, according to this database, are actually nearer to the Milky Way galaxy. My mistake, but I'd have to do more research because there's lots of variations in distance data. But there shouldn't be as many problems with nearby galaxies such as M31, because in very large telescopes using longer exposure times, you can resolve stars that have a fixed magnitude so you can determine the distance. These could be Cepheid variables, RR Lyrae variables, the rate at which they pulsate, and the brightness and dimness which they achieve at their maximum and minimum tell you something about the intrinsic luminosity. So this database is saying M31 is 3.4 million light years distance. It is huge, 3 degrees by 1 degree. So there's no way it's going to fit onto this screen. So we're going to have to spend some time, if not this evening, in the future, sweeping this galaxy to the various directions to be able to get a sense of it. Okay, what I'm seeing immediately is we are definitely masking out the very core of the galaxy. It's just way too bright. We're also getting some imagery of very dark lanes, and within that lane, located down here, you can see regions that are actually textured regions of dark nebulosity. We are looking at the very core of the galaxy, and no, that is not a black hole in its center. Now notice the degree of detail. Look at this, dark nebulosity. Now all of this region here is just the beginning of the spiral arms. It's the part of the galaxy that is only beginning to, the very core of the galaxy, as we saw in that NGC earlier. And now you can see going out into the distances are the various spiralicities that comprise the galaxy as a whole. So this is the core. It's perfectly centered. I could play with settings and see if I can get rid of that masking region in the middle of the galaxy, and I will do that. But let's, if this camera does not run out of battery before I'm done this evening, but let's take a sweep. I'm going to randomly move the galaxy 5 clicks, which basically moved, from what I can tell, it to the 630 position. Now you can see the image beginning to regenerate itself. So I'm going to let it do it, and I'm going to come back to it and move it 10 clicks in the opposite direction. So here's the regenerate image. 5 clicks towards the 6 o'clock position. Now I'm going to go 10. Let's see which way she jumps now. Where I expected. And we'll give her a chance to regenerate on the screen again. Okay, now we have the regenerated image of the galaxy, and we're basically seeing the core plus the edge on dark lane that's presented. The presentation of the galaxy is kind of like putting your hand at a 45-degree angle and observing it. You can see all kinds of detail there. Let's click it over 5 times and see what reveals itself next. Give that a chance to regenerate. Now here's our regenerated image. Notice the detail here with the dark bands and the spiral arm extending off towards the 730 position. Let's go in the other direction 10 clicks. And with any luck, and go down 10 clicks. So we get the other extension. There you go. There we should have a pretty good view of it. Now one of the things we're going to notice in this as it regenerates is you're going to get what are called hydrogen alpha region. These are areas of ionized gas where new stellar clusters are forming out of dark nebulosity. There is actually an NGC associated with it. I'd have to look it up, but that is something to look for even in a small telescope. I've seen it through a 6-inch scope on a decent night of seeing. I'll give this a chance to regenerate. So here's our regenerated image of M31, shifted down and to the left on the screen, not knowing exactly what sky position that is. Just a relative position. I'm going to drop it down a little bit further till we get the core towards the lower left-hand corner, and shift it over so we can see more of the galactic extension. Now keep in mind, all we're seeing is about 20 arc minutes of the galaxy at any given time. I will have to spend some time in the future, if I get a chance, over the next couple of days before the moon becomes too much of a factor. Let me see if I can get the core over the left more. In which I actually do kind of, kind of a tour of the galaxy as much as I'm able. See if we can keep the core in there. Alright, I'm going to let that cook for a little bit. While waiting for that image to regenerate, I decided I was going to play with some of the shutter speeds. There we go. We're still getting that overbright core. We're losing much of the detail of the galaxy by dropping it from 256. I thought I was at 128 flood. But I was actually at 256 flood, which means 16-second exposures. Now, let's have another look. If I can manipulate this thing well enough. No. Okay, let's go to 128 flood. Now, this should be the 9-second exposure time. Now, this shouldn't cause as much of a core darkening due to overexposure. But there's the view of the galaxy at 128 flood. So it's very clear to me that if you really, really need to see some absolute detail and don't mind the black bodies at the core of overbright studies, going to 256 flood is the way to go when it comes to seeing really, really faint contrasting detail. Let's give this baby a chance to regenerate, and I'll play with the AGC max in a second as well, which is not maxified out. It's at 36 decibels, can go to 44.8. Well, very interesting. Seemed to be a bit of a stall in this. I have maxed out the settings. 256 flood, 44.8 auto gain control, and frankly I don't think we're getting the image I was seeing initially. Maybe it's just taken a while to regenerate itself, but here's the core of M31 once again, and it doesn't seem to show nearly the detail that it was originally. So let's go back and have one last look at M110 and then see how that compares to the original, which was 36 AGC and 256 flood. Notice also the core is not nearly as maxed out. Now, it's quite possible that I'm now getting high thin clouds that are making it difficult to achieve the kind of imagery we had earlier on. But let's go ahead and switch to M110, and then we'll carpe nocte out for the evening, and that should be a nice final comparison. Yeah, let's give that a shot. Okay. So here's Messier 11110, supposedly. Should be generating itself on the screen. It takes about 16 seconds at these maximum settings, which is a little higher than it was originally. And then I'm not seeing anything. M110. I am seeing a bit of a galaxy right here, however, so what is this? I am perplexed. I'll try M32. Messier 32. It doesn't look quite as nice as it did originally, even though I pumped the auto gain control up. Excuse me. So the sky conditions may be deteriorating right now. I just can't quite understand why M110 wasn't appearing on the screen, but at least we're seeing M32. Let's go back to 110. Let's see if we get any kind of image other than that faint galaxy I thought I saw. Stars are generating. No galaxy. How peculiar. It'll just disappear like that. Well, I'll tell you what, Jupiter is risen pretty high now. I'm going to go ahead and see if I can experiment with a little bit of the use of the magnification function. The views have been very poor on Jupiter and Saturn so far, Xander settings. So maybe we'll puzzle through the problem. I'm not seeing the scope poking itself at the roof, so I can't quite figure out what happened to Messier 110. Very odd. Sky conditions? Possibly, but there is a galaxy right there, very tiny. Alright, well, here's a view of Jupiter, and it doesn't look very sharp. Oh, battery's running out, sorry folks, but I'm having to play with settings, 1/4000th of a second, 6 decibel, and the e-zoom function. It's too cold, battery's dying. Carpe noctem.